when you're multiplying radicals, you want to use your head a little bit because you have a couple of choices here. And one of the things you might think, well, basically what we're going to do is anything that's outside the radical, multiply those together, and anything inside, multiply those together, and then simplify further if you can. But the thing is, you guys should be doing this mentally, and I don't really necessarily want to do 18 times 24 in my head. And the thing is, I can see some perfect squares in here, and I can see some perfect squares in here. So I'm actually going to take the step of simplifying these radicals first, and then I'll multiply things together. I won't do it this way every single time, but when these numbers inside look pretty big, and I can see perfect squares right away, it's just usually a better option. The only problem is when you get to the end of the problem, you might have to simplify again. So looking at this first part, if I have 5, 18 is 9 times 2, so that's the perfect square there. The square root of 9 is 3, so this becomes 5 times 3 root 2, or 15 root 2. And then this guy, 24, the biggest perfect square that goes into 24 is 4, so that's 4 times 6. Square root of 4 is 2, so that becomes 2 times 2 root 6, or 4 root 6. Now, unlike addition, which has to have like terms, you can multiply anything you want. Multiplication is a little bit of a stronger operation, so you don't need things to be exactly the same. So now what I'll do is I'll take these outer numbers and I'll multiply those together. They make 60. And I'll take these things under the radical and multiply them together, and they make 12. And now I've got to look at the problem just one more time and make sure there's no more perfect squares that I might have introduced by putting these numbers together. And you can see that 12, there's a 4 in there. So 60 root 12 becomes 64 times 3. The square root of 4 is 2, so it becomes 60 times 2 root 3, or 120 root 3. I will say you could get the same exact answer by taking this from the very start, going 5 times 2 is 10, 18 times 24 I think is 432, and then try and break this 432 down. It can't be 432. Yeah, it is 432. But that's just a lot harder to look at this and see what the perfect squares are that go into 432, which is why we're going to kind of do it more at the beginning and then once again at the end, as opposed to all at once. So good luck with that. Be patient with yourself.